In this video, we're going to use parametric equations to simulate a stopwatch within Desmos. So you've got your time here. So time is ticking away in seconds. So by the time it gets to, let's say 60 seconds, this second hand, so normally it starts here. The second hand would have done one revolution. The minute hand, the minute hand normally starts here. By the time it gets to 60 seconds, the minute hand would have moved across by roughly around about this much. So by the time it gets to 120, the second hand would have done two revolutions. So this is 60 seconds, and another one would be 120. But then the minute hand would have moved 2 minutes. So all the way around here would be 15 minutes, and so on. And then we also have to incorporate the hour hand. So time is ticking along. So we're going to imagine this as like seconds. So let me just illustrate it. So here's an example. All three hands start at 12 o'clock. So as the second hand ticks away, the green line here represents the minute hand, and this is the actual hour hand. So by the time the green line, by the time it makes one revolution, the red line would have done 1 hour. And don't forget, there were 12 hours in one revolution. Okay, so that's our aim. So let's try and start from scratch. So create a new table. Create a new graph. Okay, first draw our circle. So our circle would be A cos t, comma A sine t. So it's just simply a circle of radius A. So add a slider. So that's our circle. We want it to range from 0 to 2 pi, 2 pi. Okay, so that's our circle at the moment. The idea is this. Well, let's add our particle first. So let's add our particle. So our particle starts. Hang on, let me think. A cos B, comma A sine B. So B is going to act as our time. So add our slider. So our time ranges from 0 to, let's say, 5,000. So this is like in seconds. So that's our particle there. So as we press play, it's going to whiz around. Let's slow it down. Actually 5,000 is a bit fast, so let's change this to 2 minutes, 120 seconds. So now if we press play, it would do this, but the thing is, it's going the wrong way, and when time equals 0, it starts in the wrong place. It should start at 12. So hang on. So simply having A cos B, comma A sine B is no good, because it starts here and it's going in the wrong direction. So if we wanted to start here, we would need to do this. A cos B and then plus 90 degrees, pi over 2, and then comma A sine, and looking at the angle here, we want to inject 90 degrees in there, pi over 2. So this will allow our particle to start in the right place. So let's test it. So going to this particle here, inject 90 degrees in there, pi over 2, pi divided by 2. Close it off. Hang on, close it off, and then we need to do the same over here. Add pi over 2, and then close it off. So hopefully that will start in the right place. So now it starts in the right place. But the thing is, it's going anti-clockwise. We want it to go clockwise. So we will need to do this. First we need to get the whole angle here. we need to get the whole angle, cut it up into 60 equal pieces, because we want to simulate seconds. There are 60 seconds in one revolution. So to simulate that, we would get the whole angle. The whole angle here is 2 pi. Get the whole angle, cut it up into 60 equal pieces. Cut it up into 60 equal pieces, and then stick your time here. In our case, it's b. So the idea here is this: we get the whole angle. Cut up into 60 equal pieces, like this. Just imagine there are 60 equal pieces. So cut up into 60 equal pieces, and then if you stick your slider b in there, as time ticks away, let's say b is 4. Let's say time is 4 seconds. So it means it would tick 1, 2, 3, 4. Or if if you want it to go the other way, you stick a minus in here, because you want time to tick in the negative direction. So when it's -3, so if you stick a minus in there, when b is, let's say, 3 seconds, it will tick in the negative direction. So it's 1, 2, 3. So the idea here is to cut up into 60 equal pieces. So let's start again. So it would be this. Currently we've got a cos b plus 90 degrees, and then comma a sine b plus 90 degrees. This is currently what we've got at the moment. So we want to cut up into 60 pieces, 60 equal pieces. So we want to get the whole angle here, because we want to simulate the second hand. So get the whole angle, cut up into 60 equal pieces, and then stick this b in here. Stick this b in here. So going to here, we will need to do this: 2 pi over 60, and then stick a b in here. So this we'll cut it up into 60 equal pieces, and then because we wanted to go clockwise, we need to stick a negative in here. So we've got to put this into here and into here. So let's put it to the test. So going to our particle, the green particle, when t is 0, it starts in the right place. But the thing is, we want to cut up into 60 equal pieces. So 2 pi, and then divided by 60, because we want to cut up into 60 equal pieces. And then do the same over here. So it's going to be 2 pi, and then divided by 60 equal pieces. So now, by the time it gets to 60, it would have done 1 revolution. So let me just move this to 60. Let me just move this to 60. You can see that it's going to do 1 revolution by the time it gets to 60. See this b here? By the time it gets to 60, it would have done 1 revolution. See? And then when it gets to 120, it would have done 2 revolutions. But we want it to go clockwise as opposed to anti-clockwise. So stick a minus in front of that b. So that would be this thing here, and then stick a minus in front of that b. So that would be this thing here. So now, if you press play, it will go clockwise. And by the time it gets to 60, it would have done 1 revolution. Anyway, in the next video, we will incorporate the minute hand and the hour hand. Okay?